Hey everyone, so today we have Alpha again. You already know who he is, don't have to do much of an introduction. But today we're going to be doing a coding interview, leak code based, and he's just going to do it in Java. So, yeah, Alpha, want to just say why you're doing this stuff in Java?
Yeah, so I just wanted to learn like a static compiled language. Because I already know TypeScript, I feel like knowing like Python or something, I can easily just go to that if I need to. It takes me like 5 minutes. So I was trying to learn something completely different, I guess. Just so I can like have that knowledge. Also, yeah, I guess in the future if I want to like do more, back end or infer or that type of stuff. Yeah, like some companies are interested in that kind of stuff, and yeah, I feel like I can kind of have all my bases covered then, because if they want Python, I do like TypeScript, JavaScript, it's like the same thing. And then if
Yeah,
they want some compiled thing, then I have that as well.
yeah, that makes sense. And yeah, I'm just going to hop straight into the question then. We're going to try to do two questions, and
All
let's
right.
see how fast you can do it. If we still have time, maybe we'll do a third. I don't know. It
All
all
right.
depends on what you're trying to do.
Yeah, I might have to ask the AI assistant for what's it called?
Yeah, go ahead. Like,
Syntax.
this is life these days.
It's life these
So,
days. Okay, okay. Peak element is an element that's strictly greater than its neighbors. Find a peak element. All right, all right. Runs an n log n. All right, log n. Okay. All right. So there's one, it can be one number. Okay.
yeah, so we're just trying to find any peak element in an array of numbers, and a peak element is a number that's greater than its neighbors. So 3 here is a peak element. It's actually the only peak
Right.
element here. But pretend there
Yes,
was
I
the
think.
boundaries are negative infinity. So even if we have 5 here, 5 is actually a peak element, and we could actually return 5 too. There's multiple answers. We just need to return any of them. But
Right.
the main constraint, like you could just assume the bounds are negative infinity. And the
Right.
main constraint is that we just want to do this in log of n time.
Right. So yeah, so I'm just gonna handle like here, I'll write down kind of quickly what I'll do. So I'll just handle like the just to make the code easier, the like one number or the ends are a peak and like some checks. And so if that's the case, I'll just return those. So if it's one number, it'll always be a peak. If the end is a peak, I can just check for that quickly. And then after that, so I think there's guaranteed to be a peak. Like you can't have not a peak if numbers are different. So yeah, guaranteed peak. And then it's just going to be like a binary search of like if my number is greater than both, return that. Or what are we returning here? Index. If it's we can compare it to like the left and the right. So if it's like greater than the left, then you can kind of picture it like a mountain. So
I mean,
like a
there's a
mountain
drawing
greater.
order. You can hit this drawing mode too if you wanna.
Oh yeah, let me do that. Castle Ridge. Okay, yeah. So basically like so it's gonna look one of three things. It's either gonna be a peak, or it's gonna be here, or it's gonna be here. And so I can just compare it to the element like to its left. So if it's like bigger than the element to its left, then it's on this side, which means I need to binary search this way. And if it's smaller than the element to its left, that means the peak is on this side, so I'd binary search the other way. So I just
Okay.
yeah, basically that's all I would need to do then.
What if you're just on like this case or this case?
You're a little bit. Let me zoom out or something.
Or I'm
Wait,
on the
how
side
do I?
here. Oh, you don't see here? Me
No, I'm
drawing?
trying to. I got it. I got it. Okay, so what am I? What am I at? Try one
So
more time.
okay, what if you have just a slope like this? That's the input of numbers. It's increasing.
Yeah, so if this is the numbers, then I'm just gonna do checks in the beginning and I'll just return that because that's the end. So I'm gonna check the ends in the beginning. So then if it's not in the ends, it has to be in the middle, and then you can't have this case.
You can't have
So
this
it has
case.
to be like this. No, because if it's like strictly increasing, I'm just gonna check if the last number is bigger than the second to last number, and if it is, then that's a peak, and I'm done. Right? Does that make sense? Like if I have like 1, 3, 5, 7, I'm just gonna check the ends in the beginning. So like if this is bigger than this, then this is a peak and then I'm done. And
Okay.
same thing here. If this is bigger than this, then this is a peak and I'm done. So it has to be like a mountain.
Yeah. Yeah, that makes sense. I feel like we can have the algorithm though just general and not have to check that case. Like what happens if we
I
look at the
could, but I'm
middle
gonna
one?
be comparing numbers to like their neighbors, and I don't want to get like out of bounds.
I see.
So like, so I'm only gonna compare the inside part. So that's why I'm gonna do the check for the outside ones first. I mean, yeah, you could probably do it all in one, but it's gonna be like just saving me a lot of time to do the checks ahead of time, and it's not gonna like make it slow or anything.
Okay, go ahead and implement it then.
Okay. So I'll just write this function. So let's actually add the tests first.
Wow, test driven development.
Yeah, I was trying this. It actually works surprisingly well. So I'm just gonna write the test first, and then I can run it, and then like, yeah, it works very well to be honest. Okay, so we'll try like what would just call this like find peak or something. Um, and so we'll try it on just like one number, and it should just return that number. And then we'll try it on a couple more. So we'll try it on this one. And we'll try it on this one. Okay. And then we'll try it on a sorted array as well. So like this. All right. Yeah, so now I'm just gonna make this peak. It's gonna take int array nums. So yeah, I'm gonna check for those things that I said. Okay, yeah. So if and I'm gonna assume I think the constraints had one or more. So if num's length equals 1, then we can just return that guy. And then we're gonna check for the two ends. So if num 0 is greater than nums 1, return num 0. That's the left end. Same thing for the right end. And then the other one. It's 2. So return that one. All right. So now all we have to do is check all the numbers between those so they can't be the end, and it's guaranteed to be a mountain now. So it's going to be a lot easier. So we can just say like int left equals 1, right equals num length minus 2, and then just do a binary search. E. So I think in Java you have to do it this way because you might get overflow depending on constraints.
I usually just do it that way, even in Python.
Yeah, I mean you can just always do it this way. I feel like it's just a little bit less intuitive than like the half one. So, but yeah, you can do it in this way in every language. Yeah.
In
And then
Java, how does it handle divisions if the division is a float? Pretend it does
yeah, so it's
static.
really nice actually. So if it's an int, it will make everything an int. So it's very convenient. So like this will just be floor divide.
But it takes the
If
floor.
it was a float, what was that?
It takes the floor.
It takes the floor, yeah, because like the left is an int, the right is an int, so it takes the floor. If one is a double, then it will do a normal divide with no floor. Yeah, so it's actually very convenient, I think. Okay, so if num's pivot is greater than the num's pivot minus 1, and num's pivot greater than num's pivot plus 1. And I think one of the constraints was two numbers can't be the same, so this is the answer then. This is actually wrong, by the way, looking back. So this needs to be 0, 0, and then because I think they want the index. All right. So then we have two more cases. So if num's pivot is greater than num's pivot minus 1, that means we're like going up the mountain. It has to be on the right. And then you can have an else. And I think in Java you need a what's it called? A default return, so we can just have this. Okay, so let's give that a go. See if I messed up any syntax. All right, so 0, so that's correct. 4, yeah, it should be the biggest. -1, so that's not correct. So it should be, yeah, definitely not -1 there. Okay, so for the ones that, for the binary search one is not correct, so let's double check why. Oh, okay. It has to be this way, right? Okay, 1, 2, 3, 4, 5. Yeah, okay, it's good now. Yeah. Yes, I do find this, like, writing the test ahead of time actually is very useful. Because you know exactly what broke very quickly. So I started doing that.
Alright, so see if this
Obviously with leak code it'll give you stuff, but if you don't give me anything, I found it quite good.
Okay, solved it. Quick.
Solved.
Holy. Let's ask it. Here, let me find you another one. Give me a second, pause.
Okay.
This one's sort of a classic one, but it's important to just make sure you have good recursion, like you're able to handle recursion in Java. But
LCA.
Prompt. Okay, and I have extensions if we need it.
All right. I mean, yeah, obviously did this one before, but so with this, so there's a bunch of ways to do it. One is you can like make paths and then you can like compare paths. The better way is let me go to the drawing again.
Here, let's just explain the question first for the viewers. So
okay, sure.
I'll just write out the example so I have one on
Sounds
code.
good, yeah.
So I mean we're given 3, 2, 1, 6.
Where are you writing, by the way?
Oh, you don't see?
In the drawing
in the
or?
drawing. Yeah, I'm in the drawing.
Okay, got it. Okay, yeah. No, yeah. Okay.
So,
got it.
We're gonna be given 2 nodes. Pretend we're given 2 nodes. We're gonna be given a P and Q. P and Q.
Mm-hmm.
If we pick 6 and 2 here, the greatest common ancestor is. Oh, this needs to be different.
I believe they should all be like unique distinct, or something.
Right? Yeah.
Yeah, and then I also believe that they are always present in the tree for this one.
Yep. So 6 and 2 here. We should return. This is the greatest common or the lowest common ancestor. 3 is an ancestor, but 7 is the one lowest in the tree. Pretend we put 6 and 1 here. What that means is, if we did 6 and 1, the lowest common ancestor is 3. So we essentially just need to return the lowest common ancestor between 2 nodes. It's a classic one, but it might be difficult in Java, and I'm going to extend it.
Sure. Yeah, so as I was saying, so the optimal for this, I think there's something even more optimal, but like the reasonably optimal is you basically like go down until you see a node, and then you return values when you see the node. So you return like how many nodes you've seen that match P and Q. So what that would look like is like you would use any kind of DFS, and then you would basically return. Not yet. I'm just explaining, but I'm gonna draw it right now. So like for this node, you would just return 1 because we've seen like one node that matches P or Q. Here we'd return 0, and then at 7 we'd return like the total of what we've seen, so it'd be 1 again. And then here we'd return 1, and then when we go back here, we're gonna get a 2. And like the first place we hit a 2 is the lowest common ancestor, and so we can just mark that as the node. That's the answer, and then after that we can just like reset this number. So from here we can just return like 0. So there's only going to be one node that we're going to hit a 2. And yeah, basically once we hit a 2, we'll just set our whatever variable to that node, and that's going to be our answer. So let's say if this wasn't 6 and 1, if this was 6 and 2, This would return 1, this would return 1. You'd get a 2 here. So you'd set this node as the answer, and then you'd return 0 up here. 0, 0. So once again, you're only going to hit a 2 in one node.
Yeah.
Does that make sense?
Yes, that makes sense. And what's it called? So what kind of like DFS is it gonna be? What variant?
It doesn't matter. Just any kind of DFS, like left or like in order would be fine. Or I no, actually, you just need any DFS where you visit the children before you check your current node. So I guess that's technically post order, but you can go like right then left or left and right, doesn't really matter. So I guess it would be post order.
Yeah. I
Yeah.
mean, if you if you did with it in order, would it be possible? I don't know.
No, I don't think
Yeah.
so.
Because you need
Because
to know.
you have to visit the route last. Yeah.
Yeah. Okay. Go ahead and implement.
Okay, yeah. This one's going to be a little bit more annoying to write tests for. Uh, do we have a yeah, do we have like a
We
tree
can
node or do you want me to make that as
make the
well?
tree node. Yeah.
Okay.
Just make the tree node.
All right, so we'll make tree node. And I'm just going to make one that can only have like int values for this case. I'm not going to make like a generic one or anything. So the tree node needs to have a couple things. It needs to have an int. And do I need to worry about making like the value private and all that stuff, or does it not matter?
Yeah, I'll just make it private just because.
Okay, so I can make it private, and then I would need to make setter or getters, I guess, to actually access the values. So it would be like private int val, and then the pointers as well. Okay, so we'd make like a private tree node left, and then private tree node right. And we just need a constructor. I guess these can also actually be final because they never chain. So then we just have a tree node and constructor. It will take a int val, tree node left, tree node right, and then I guess this should be public. I mean, it doesn't really matter because it's going to be in the same class as this. So, but yeah, okay. So this left field may not have been initialized. Okay, yeah, let's see what happens to make it. So this val equals val. This left equals left. This right equals right. Let's see if I have any. Okay, there we're good there. Okay, now we just need getters for all these things. So public, what is this? Int get val, turn val, and public node get left, turn left, and same for the right.
In Java, there's no way to specify optional, right?
So actually, they can all be null. I think there is an optional, but this can be null, and it will give you null, so it'd still be fine.
Yeah.
So I can declare this thing with like null. I think there is a way to actually do optional though, to like make it more clear. I think there is some stuff. I just am not super familiar with how it works.
Let's see.
But yeah, these can be like it says it's a tree node return, but any object can also be null. So it's like a tree node or null.
Yeah, because none
Essentially.
is an
Yeah.
object, right?
Yeah. So it works. Yeah. But there's a way to make it more clear where you give it like optional to let the person know like this is pretty likely to be null. Yeah. Okay. So let me get rid of this. Just use the solution guy. Get rid of this. So let's make. Yeah, we'll worry about tests afterwards for this one, I feel like, because it's going to be a little bit more difficult because there's trees. So we're going to make a static class called get LCA or something. And it's going to take a tree node root and then a int p int q or something. And yeah, I'm just going to make these static because they're like in our main thing. So we like don't want to initialize their solution. And I think this returns an int. We're returning like the int, right, where they intersect, I believe.
Yeah.
That was the problem. Okay. Yeah, so from here, we need to make a helper function that's going to be also static, DFS, tree node, node, int p, int q,
Actually, we're
and
gonna
then we need
return
some
the
place.
actual node.
Uh, we're not going to return the actual node. We're going to return or we're not. Actually, we're not going to do it. We can return the actual node. Like, what do you want to do? Do you want to
Yeah,
return the
we
actual
want to
node?
return the actual node. Yeah, that
Okay.
should be tree node.
Okay, in that case, so what I'm going to do then is I actually need a setter. Uh, Yeah, I need a setter then, and this is not going to be. Can I create it? I
What's
guess
the
I can
setter
get.
for?
So I need to, in my DFS, I need some way to set like my node to what I found. Like I can't just return because I'm. Yeah, I can't return the node here. So this is actually going to return an int. I can't return the node because I need the ints to figure out like where I have that thing. So I think what I need to do.
Well, here we're gonna be. These should be type tree node. Or wait, let's
Oh, they
see.
should be. Well, even then, it wouldn't really matter. I don't think these are type tree node. I think
Like on the leak
they're.
code, it is.
Oh, interesting.
Yeah.
Okay. Okay. Yeah. I mean, that doesn't matter. So I still need to like this can't return a tree node. This will return an int, but I need to somehow in here. Um, I need somehow in here to set a tree node that I create in here. So I think I can do like this tree node res or something, and then I can just make it here, and then I can just pass it down, and then I can set it equal to something else later. I think that'll work. Let's see what happens though. Okay, so what we're gonna do in this DFS is we're basically gonna say like if node equals null, and we can just return 0 because there are no like matches. Okay, now we need the total of like how many matches are there. So if node value equals uh okay, yeah, so I can just pass down these values, that's fine. So P for node value equals Q. We're gonna increment the total. I think I need to do like a get, right? Because it's private. Okay. Okay, now I need to calculate the left side. So DFS node, I think get left, PQ, DFS node get right, PQ. Okay, so if, or then I can add that to the total. So if this is 2, that means this is my node. So I need to actually pass a 3. Yeah, I don't know if this will work. I know how to make it work for sure, but I'm curious what this is going to do. So what if we do this? So if we say this, then yeah, so if total equals 2, so we need to set tree node equal to this node. X equals, I don't know if this will work, but we'll see. But I know how to make it work for sure.
I think x is a local variable, so it's just overriding what's in that local
Well,
variable out there.
I don't think it's a local variable because I think it's like an instantiated object. I mean, I guess I could do like a hack, or I could make it like a class variable. Like what
Or
I could do is I could, yeah, but
so,
let's see.
how do
Or go
you
ahead, sorry.
return tuples in Java? You do that too.
Uh, how do you return tuples of different types is going to be kind of a pain.
Like pair, like have you used pair Java?
Yeah, I think the easiest way to do it is honestly this. Like, I just make something that's not local, and then I can just pass that down, and then this will work for sure.
That one would work, yeah. Because now
Yeah, so I
it's
just make
res,
it
and then
like
you would
this.
just add.
Yeah, exactly.
But okay, let's try the other one. You thought it would work if we just do the x equals that or res?
Yeah, let's try this. So I know this will work for sure, so there's no need to test that, but let's try the other way. Yeah, so tree node. uh like res. Yeah. So I can make it a new tree node for now because it's going to get overridden anyway. So I can just make it like 0, null, null or something. And let's see what happens if I pass it down or if it complains or
I
anything.
feel like
I
that's
can
just like
also, yeah,
kind
this
of
is
the
where I'd
same
ask like
with
this
like
is where I'd ask the AI thing as well. Like, how do I make this thing like update?
yeah, ask it because I feel like it's just like the same as overriding it. The variable.
Hmm.
You can ask it, throw it in the AI assist. Be like, does that work?
Well, let me do
Oh
the
yeah,
rest of
try,
it
try,
first.
try.
So,
Yeah, yeah.
why is it complaining here? Method in the type solution is not applicable. Oh, because I need to pass down the x. Okay. Yeah, I'll ask it at the end. So if total equals 2, then x equals this node. So that's just node. And then I just don't want it to ever be 2 again, so I can just return like 0 or something. And then otherwise, I just return the total here. Okay. So yeah. So I think this will be fine. And then yeah, I can just do DFS of root and then p dot get val, u dot get val, and res, and then return res. Okay, so now we need to actually make this tree and test. So let's see. Okay,
Just
so
make a very small one too. Like just
yeah, maybe let's try like just a tree with two nodes or 3 nodes or something.
yeah.
Or let's try a tree with two nodes. Yeah, so and uh, var equals node. Okay, so literally it'll just have like 0. Uh, let's see. Yeah, I think for the sake of testing, can I just change these tree nodes to ints because then it'll be easier? Like I know it'll be exactly the same thing. There's
Let's
kind of
look. Yeah.
nothing to be gained here.
Well, I'm gonna ask a follow up question. Is the thing.
Okay, cool. Okay, cool. So in that case, let me do. Okay, so here I'll just make like a new tree node here, with value like 5, and then null null, and then this is null. Okay, and then I will want to say like tree node or var p equals new tree node. So this value needs to be 0, null null, and then the var q new tree node. What's the other one? 5. Okay, and then we can go. Um, or let's do this. Whoops, not that.
Well, we want to compare by reference, or I guess it doesn't really matter, because you're right
Yeah, I mean
now.
they're all different, so it's not gonna matter. Um, or I guess we could do we could do by reference, I guess, if you want to. So here we should basically get cur. I think in this case, so we want to say like get LCA of cur PQ. So to compare by reference, I think you just do a get equals cur. This method is undefined. Did I misspelled it? Okay. So let's see what this gets, and we have to debug further. False. Okay, so instead of this, let's do val or get val, just to see like if we're even getting anything. Okay, we're getting 0. So that's this initial value. So let's just make this like this so we know something happened. Okay. And let's also do a print here. Oops. Just to make sure we're actually doing something here. Looks like we're not. Okay. Yeah, looks like we're not. Because we're basically printing, let's see. We're printing here. And Or are we doing something? No, we are, right? Because it just have the -1. I think that is correct. Yeah, okay. So we are getting to this, and this is node 0, which should be the answer. But then this x equals node is not working.
So
So
like
basically,
once it
yeah.
leaves here, it goes back, right? To or let's see.
Yeah,
Res
yeah.
here is
But
not changing just because you passed in here.
yeah.
Like if you
Yeah,
did
so
the same print after, it's gonna go from like -1 to 0, right? Negative. Maybe like you print it out here. It's gonna
oh, like res get val or something?
yeah, it's gonna go back to -1 there. It's just gonna
Yeah,
print
yeah,
0.
that's what I'm saying. Yeah, I'm
Yeah.
saying this isn't working. Yeah, like this what I was saying isn't working for sure. Yeah. I I definitely know that like if I just updated its value, it would work, right? Like if I passed it here and I just said x val equals this, but then
Yeah.
it wouldn't be the same by reference, right? It would just be the same value.
Mm-hmm.
Yeah, so I think so let me think what's going on. Oh, because I guess it's just making like the low well, yes. I mean, you never really do these things where like you pass an array and then you just like modify the array to a new array. So I don't know how that works exactly, but yeah, that makes sense that it's not working. So I guess yeah, the alternative is just make an array here, right? Make an empty array and then just add to the array, and that works for sure because you're not changing the reference. You're not changing the address. Where I think this changes the address.
I see.
Yeah. So I think, do you want to go with that approach then? So instead of this tree node res, we just make an array.
Like what? I think that one's okay too. Just also hacky. Because in Python, we probably do this, right? We just return the node.
Yeah. Yeah. Yeah.
So like
That no. Yeah, for sure.
you can do this too in Java. Java. I've interviewed candidates and they did this in Java using the pair API. So they defined that we're gonna have a pair that returns an int and the tree node. So
Uh huh.
maybe try
So
doing
maybe
that.
look up.
Yeah, look it up
I
on
guess
the
I
AI.
can
Just
look
look
up
up
how to do
pair.
that with AI thing.
Yeah, yeah.
Okay. Yeah. Let me do that. So let me
Because
go
that
back.
will, because you'll have to do this a lot. I've seen like most candidates they pull out pair.
No, I'm definitely. Wait, what happened here? So this was, I think, oh, it's because you were typing and okay, I see.
Oh,
So, okay, so here I need to, yeah, I need to return a pair. So I need to change this thing. So here, yeah, I would just say like x equals node, but this doesn't work. Okay, yeah, let me do that. So in this function, or I guess, yeah, let me just, do I have to copy my code or something? Let me see.
or
Okay,
just ask
so,
like how to use pair. Like don't copy and paste the whole thing.
oh
Just ask
yeah,
how to use pair and
how,
then augment it. How
how
to
can I
use pair?
use
Yeah.
pair to return a value and a tree node together in my DFS so I don't have to pass this node down. Okay, yeah. No, it definitely works. Let's see.
What is
So
this?
where's the pair?
Is this
Is it just like an
C plus
import?
plus?
Oh, yeah. I don't know how that happened. Give me this in Java instead. Yeah, that was weird. Okay, so let's read it. So pair you can implement pair-like structure. In Java, we don't have a built-in.
What the heck?
Okay, well, if it doesn't have a built-in, that's going to be annoying.
Like okay, how do you ask it? How do you do tuples? How do you just return simple tuples? I'm just curious.
I mean, you can definitely make a class, so that would work for sure. Custom class, abstract. Yeah, I'm not familiar with this. I could have sworn there was a pair, like an actual.
Maybe they
Yeah,
removed
so I
it.
could, so you could do this.
Like
I'm gonna
simple
look that up
tuple.
later. Yeah, so I could like make a class, but I feel like that's gonna take a while. Yeah, so maybe this is something I can like research in my own time, I guess.
Okay, there's map
Because
entry. There's an entry integer node.
where's that? Where are you seeing that?
Here, I'll point the very last piece.
Okay.
Like, this is the code. See, this is the stuff that makes Java annoying on the interview.
Oh,
So you can
where'd you
see
write? Oh,
up here
this.
21 to 20. So we return an
Uh
empty
huh.
tree node. And then from there, you see that?
Okay, public map entry. Oh, I see. It literally makes a. New abstract map. That's weird. Yeah. So this is like a key value pair in a map. I mean, this is also kind of hacky, so I don't know if
Right.
this is better, but sure, let's try it. Okay, so integer tree node. So how do you make the entry here? This, I guess. Okay. So this needs to be 0 and like null then. Okay. Then I need to read it. Okay. So left result. Yeah, I feel like this is only difficult if you like go down this approach, which I wouldn't do. Okay, so this is right. Okay, and this is like, how do I access the actual things here? Get key. Oh wow, this is very hacky. Yeah, so this is basically like you're making a key value pair where your key is like the left return and your right is your right return. So this is like I would argue, like I said, more
Okay, in
hacky than
Java
the
they
other
got
one.
rid of it.
Interesting.
What did they do? How do you?
Okay, so in that case, we would return this. Yeah, like I would honestly argue that array is better here.
Yeah.
Okay, 0 and add no, what's it called? Node. And then here.
I mean, yeah, like there's multiple different ways. Back when the pair was around,
I know in C++
that was fine.
there's a pair because I used it a little bit. Yeah, so total no. Okay. So then we get rid of this. We get rid of this. Equals.
Oh yeah, both solutions are
Get
good.
rid
I
of
was
this.
just exploring different
No, it's
options.
fair. Yeah. I mean,
Just
it's good to like learn these things just to see if there is something better. Like, if there was something pretty clean, then that would. Okay, so now, yeah, get value. Okay, so let's give that a go.
you can remove this X node, right? Oh, that's gonna cause issues.
Yeah. See, I'm gonna move this thing so I can actually see. Okay, 2 errors. Oh yeah, so I'm return calling that guy. And yeah, that's just kind of what I'm spending a lot of time on, just like trying to see if I can write something cleaner. Okay, so this is working. It's 0 now. So I can make like a bigger tree if you want me
Just
to,
make a
or we can just say
slightly
it's
bigger
working.
tree. Do a add a right child to this guy right here. This guy.
Sure.
And then just do like 3 and 5. What should that return 0?
I don't think you wrote this correctly, but let's see. 0. Oh, this is the right. Wait. Oh, I see. This is the right child. Yeah, so 0, 3, and 5. 3 and 5. Yeah, it should be 0. And if we try like 0 and 5 or something, then we should get. I mean, they should all get 0.
Okay,
Yeah.
I'm doing. Okay, we're gonna slight. This is gonna make this slightly more difficult, but pretend
Okay.
we can have um, nodes with the same value.
Uh-huh.
How would we solve this question now? Nodes can have the same
Okay.
value. Pretend this
So
is.
going back to the picture, I have full screen. I think open a new window. So if we have nodes with the same value, first let's clarify like what we even want here. So let me just toss this. I think you can go here and do DSA or something. Data stroke. Yeah. Okay. Did that work or? Yeah. All right. There we go. Nice. So then, so we have this tree. So if nodes can have the same value, like what do we even want, right? Like let's say we have 5 and 3 here and like 5 and 3 here. Like what are we expected to do? And yeah, like
Well,
PQ
we're,
is
we're
like
gonna be
5 and
given
3.
references. Pretend we're gonna be get reference P in here,
Uh-huh.
right? We have. So what's the like? We're gonna be
Oh,
given
I see. So we're
references.
so we're not looking for values, we're looking for references now.
Yeah, exactly.
Got it. Okay, so in that case, I think the same value doesn't matter at all, and it's kind of the same thing. So instead of comparing by value, we just need to compare by reference. So like, let's say, we have all these same things, but like the reference might be like here and here. Still going to be the same thing, right? Like it would just go up the path and it would be this node.
Yeah.
So we have to change our function where instead of passing like this int, we have to pass down the actual node, and then we have to just compare by reference.
Yeah.
Yeah. Okay, cool.
Yeah, I'll just modify this real quick. How would we modify this right here, though?
Uh, yeah, so this needs to actually be a node. So maybe we make them first, right? We will like make this first, and then we do instead of new tree node, we do like P and Q or something,
Yeah, exactly.
right? So yeah. And so what we have to modify here is instead of this P get val, this has to be like these have to be nodes. And then the rest of it's the same. So if null, so now it's not if node, it's just I think you just do a like if you do an exact equals, it will compare by address. So that would basically solve what we need. And I think the rest of it's the same. So I think this should be fine. Let's see if I missed anything. Yeah, okay, cool. We can try
So,
something bigger as well.
wait, what's chat
Yeah.
saying? So, doesn't it always compare by ref? This is comparing by reference, right? No P and Q.
Comparing by address, yeah.
But that's the same thing, right? That's what we mean by.
Same thing, yeah.
Yeah.
Because yeah, like that's what we're looking for, right?
Yeah.
So we're looking for it to be the exact same thing. So yeah, in order to compare by like values, you'd have to make a. I mean, you can make a custom function. You can also override the equals function.
Yeah.
Like every object has an equals. You can just override to say like, oh, in order for it to be equal, don't compare by reference, but do like val equals val or
Yeah.
something or whatever
Yeah.
you
I
want.
see. Okay.
Yeah. Yeah, I mean, I can make it bigger, but it should be the same.
Yeah. Cool. All right. Nice work. Yeah. Nothing really to say. I feel like just this question would take you like 5 minutes on Python, but it just takes way longer on Java. That's the thing.
I mean,
So,
it kind of depends, right? If you're pushing for things that are hard to do in Java, then yes.
yeah, that's true.
But I would argue that this solution is not any better than like an array that I
Mm-hmm.
was saying earlier, and then I could have done that very quickly.
Yeah,
So
that's
it's
true.
like, yes, if you're like, I know Java can't do this, but let's do this, then yes, it will take a very long time.
Yeah. I feel like
Yeah,
even
yeah.
without that, like that was only the last 5 minutes
Uh-huh.
that we were doing that. That last little bit,
Well,
the map entry.
Well,
I
you
don't
also
know.
wanted, once again, you wanted some specific stuff. Like I
Yeah,
couldn't copy a tree node. Like a lot of times for these problems, I think they just give you the class
that's true.
for free.
Yeah.
And you also wanted like private methods and static, like all the other stuff.
True.
So, I mean, I could argue kind of the same thing in Python, right? Like, okay, make this tree node, make everything private and make getters, and you're not allowed to access the variables. Like, is one longer? Like, you have to write the same
Yeah,
exact
that's
stuff,
true.
right?
Yeah.
So,
Yeah, I
yeah.
guess just turning to now we know returning tuples is annoying. Not really possible, but
Yeah. Yeah, so you can return a tuple. Like I said, you can make a custom class once I get better at Java. That also doesn't take long. Like I can make a class called pair where the pair will have, like you can literally just do this, like class pair, and then it can have like int val and
yeah.
then like tree node or something. And then you can just return that and initialize it, right? So you can just say like pair val or what's it called? Int val tree node, and then you just do like this val equals val this node equals node, and then you can basically just return like, or sorry, not return, but you can instead of returning that tuple or that weird thing, you can just initialize that and return that, and
Yeah.
that's not a lot of code, right? So
That makes sense, yeah.
yeah,
That would have been fast too, eventually. No, good work.
yeah, yeah.
Good job with the two questions. Yeah, you
Thank
know
you.
Java pretty good. I think. Oh yeah. Well, one thing that Java has too is they actually have the tree map. Do they still have that? That
Yeah, they definitely
balanced
have a tree
binary
map.
search tree. That one was
Yeah,
good.
so binary, so that is kind of similar to Python has sorted list. It's pretty rare, but it's also very useful. So sorted list is like it gives you a sorted list for free. So like if you put in items, they'll be sorted. and then you have like login, lookups, login, inserts,
Yeah.
login, whatever you want.
Interesting.
So it makes a lot of problems like super easy, and if you didn't use it, it would be like way harder. So it's like the same thing.
I see. Yeah.
Like I don't
Cool.
know if you've seen that before. There's like a
I didn't
sorted
know. I,
containers.
I
There's
never
a
used
sorted
a
containers in Python.
I never used a sorted container in Python. I thought back when I was still in school or doing new grads, I straight up would just switch to. I would switch to Java if I wanted to do.
That.
Yeah.
Okay, yeah. Yeah, sorted container has like sorted list, sorted set, sorted dict, but sorted list is like the same as yeah. You just need sorted list
Is
basically.
this
So it's
actually
like
doing a tree map or something underneath? This sorted list?
sorted list? I think so, yeah. You can look it up. You can just
Yeah, I'm looking
Google
at it.
sorted containers.
I'm looking at it right
Yeah.
now. Let's see.
Yeah. So you just Google sorted containers. And then it has pretty good docs. I think the second one is the one I used, but yeah, this one also shows. So you could do binary search, you could do insert, you could do lookup, you could do remove, like all that stuff. And they're all log in because it's like a under the hood tree.
Let's see. Let's chat GPT is, or let's look it up right here. Is
Yeah, for some leak code problems, it's definitely like a cheat
way
code.
faster,
So
right?
yeah,
Yeah, I never tried this.
yeah, yeah.
Oh, it's called sorted containers.
Sorted containers. Yeah. So you see the top line from sorted
You
containers,
gotta
import
import it
sorted
though.
list.
You have to pip install it. No.
No, you don't.
Oh, really? The one I'm seeing is pip install.
Well, in I
Oh,
think in
sorted list.
leak code you can import. I don't know. Maybe it depends. Like you can try in CoderPad, switch to Python, and try it.
Oh
I
yeah,
think it probably
it's
depends. Like you
okay.
might
See,
have to
this
pip
is
install
it's not
something.
part of the standard library. That's why I was getting confused. I don't think.
Oh, I
It's,
see.
it's saying you have to pip install it.
I see.
Cause yeah, I was wondering. I was like, I never knew they had that. Otherwise, I'd never switch. But it looks like it's
I know in leak code you don't need to pip install because you can just like import and it works. So maybe it's already imported. I don't know. I
interesting.
don't know what it is in CoderPad.
Oh, this is cool.
So
Nice. Cool.
yeah.
This is sick. Good job. Let me know when you want to do more. You're just gonna keep grinding up more Java.
Yeah, yeah, we can do some more. I can get better. Yeah, I think you can also like the nice thing about it is I can come up with some solutions that kind of like you're not used to because like in Python you do it in one way and you might think like oh this way is hard in Java, but it's just because in Java you just have to do it like a different way that was like better for Java. So I'm gonna try to learn more of that.
Yeah, no, that makes
Like
sense.
like the pair thing for example. Like if I could make a pair quickly, I could have just done that right
Yeah.
instead of doing this key value hack thing.
That makes sense.
Yeah.
Like, do
Okay.
you think that in production the array one would be good though, or not really? Like, you think the
No, I don't
pair
think
one is
so.
probably the most common?
I think I would make in production. I think you would just make helper things that you use really commonly. Like I know we have like JavaScript didn't have a lot of stuff, so I know we use like Lodash or something. Like I think JavaScript didn't have like built-in map, built-in whatever. So you just make like helper functions that you use all over the place, and then you could just make like a utils or whatever where pair would be one of them. Like you can just make a generic pair where it takes like two values. Yeah, this thing actually on the right that this class pair KV thing where you could take any kind of except I probably wouldn't call it like KB or whatever, but yeah, something like that. So
Nice.
I think the array thing is kind of hacking production, but also like when do you have to do this kind of problem in production?
Yeah, you don't have to do
So
this. Yeah.
I would
Even
definitely have a cleaner solution in production
even
for
one
sure.
thing that you could do in Python, I don't know if you could do it here, would just defining the public variable.
Yeah, I could have done that. That
Is it
was the
easy
other,
here
but
too,
that's
or
also
not
kind of
really?
hacky.
Yeah.
Like I could have defined the public variable in the solution class and then just reference that. That would work too.
Yeah.
Yeah.
No, there's multiple.
I think I like the pair the most though, to be honest, out of all of these. Just like make my own pair and use that. That's what I probably would use in production.
Nice. Cool. Yeah. Let me know if you ever have to do that. Any other question? I feel like there's
Okay,
some
yeah.
of them, but yeah. Cool. All right. Let's. Thanks for coming out for the
No
interview.
problem. Yeah.
Have a good night.
Okay, cool. Yeah,
Peace.
see ya.
Nice. All right. We'll be back streaming tomorrow. Alpha, thanks for pulling up.